Hi there, this is a second problem. I need to determine the stationary values of this function and to analyze its nature. This can be simplified to 3x squared minus x cubed. So, first derivative, dy dx, which is equal to 6x minus 3x squared. Our second derivative, d2y over dx squared, and this is equal to 6 minus 6x. Well, we know that at turning points, which is dy dx is equal to 0, so when dy dx is equal to 0, we have that 6x minus 3x squared, which is dy dx, and this is also equal to 0. And so this simplifies to give us x squared minus 2x is equal to 0. And so we have x is equal to 0 and x is equal to 2. Now we have our x coordinates, we can go ahead and check our second derivative. So d2y over dx squared at 0 would be 6 minus 6 times 0, which is greater than 0. It is actually a positive number. So we know we have a minimum at 0, and the y coordinate is also 0. At x equal to 2, we have d2y over dx squared is equal to 6 minus 6 into 2, which is negative, which is less than 0, and so we have a maximum here. And it occurs at y equal to, we substitute x equal to 2 here, which gives us 2 squared into 3 minus 2, which is 4. So we have a maximum value at 4 and a minimum at 0. We've found our stationary points, x at 0 and x at 2. If we were to write as coordinates, we could write 0, it's at 0, 0, and we have 2, 4. Thanks for watching this video. I'll see you in the next problem. Bye for now.